The world has reached a point where smart tweezers are being made. And today I have the ZOYI ZT-MD2 LCR meter. This model is new. I'll be checking it using another LCR meter, the FNRC LC1020E. The problem with this model is that it's too new and there's currently no English language software for it. The firmware update is available on the Chinese website. The ZOYI company's English website doesn't even mention this device. It's completely fresh. Let's see what it can do. In the meantime, I'll compare it with two other devices. The first comparison device is the ZOYI ZT-MD2. This is the previous version, costs less. If you don't need the functions available in the MD2, you can buy the MD1. This device has 3 measurement frequencies, 100 Hz, 1 kHz, and 10 kHz. The measurement signal amplitude is 300 and 600 mV RMS, but the new firmware version also added 100 mV RMS. It measures capacitance up to 20 millifarad, inductance up to 60 Henry, and resistance up to 20 megam. You can use it to check diodes and continuity. If I'm not mistaken, it doesn't transmit data to a computer. The second comparison device is the FNRC LCR ST1. Costs the same as the ZT-MD2. It measures the same parameters and has 3 measurement frequencies, 100 Hz, 1 kHz, and 10 kHz. It also measures at an amplitude of 300 and 600 mV RMS. A plus for the LCR ST1 is that it has data logging functionality. This data can then be retrieved on a computer in Excel format and viewed at any time. But I don't know how this function works, as I haven't owned this device. The ZOYI ZT-MD2 version costs $10 more. I immediately recommend getting the kits with calibration resistors. Now let's count the advantages. The first advantage is that it has a scanning mode. A component can be scanned quite quickly at 5 frequencies with a parallel measurement circuit, a series measurement circuit, and an additional parameter is measured. For capacitance, this is the dissipation factor. The second advantage. It has a comparison function. Regarding the comparison function, I couldn't find how to enable it in the manual. Most likely, this function requires additional software. The third advantage. 2 more measurement frequencies have been added, 120 Hz and 100 kHz. The fourth advantage is that it can measure DC voltage up to 30 volts. The fifth advantage is that it has a built-in generator which outputs 6 waveforms with a frequency up to 10 kHz and a sine wave signal with a frequency up to 100 kHz. And there is a data logging function, and this data can then be viewed. Unfortunately, the software is currently only in Chinese. MD2 remembers the operating mode that was before turning it off. It's turned on with this button. You'll need to get used to the controls because there are 4 buttons, and you'll be confused by them for the first few minutes. The next button allows you to select the parameters you'll be measuring. There is an automatic parameter selection mode. I press the button and select resistance. It measures resistance up to 10 megam. In the range up to 1 megam, the accuracy is 0.5% plus minus 2 digits of resolution. It measures capacitance up to 22 millifarads. In the range up to 1 microfarad, the accuracy is 0.5% plus minus 2 digits of resolution. It can measure inductance up to 10 Henry, although the manual states it measures up to 60 Henry. However, the manual also states that it measures DC voltage up to 16 volts, but in reality it measures up to 30 volts. There is a diode test mode. It measures voltage drop up to 0.9 volts, no higher, and it can also be used for continuity testing. The DC voltage measurement mode, the scanning mode, the generator, and that's basically it. To enter the settings menu, press and hold the 4th button. And to exit the settings menu, you also press and hold this button. The only languages available are Chinese and English. You can move up and down the menu with the 2 middle buttons. There is automatic screen rotation. This is very convenient if you flip the tweezers over or if you're left-handed. Backlight, sound, auto-off timer, measurement speed, slow, medium, or fast, measurement model, automatic, series, or parallel. When measuring, the second parameter can be selected automatically, or you can specify impedance, reactance, or phase shift angle. There is an option to disable functions you don't need. For example, if you don't need voltage measurement, you can disable this function. There is closed channel calibration, open channel calibration, and calibration with resistors. That's why the calibration resistors are needed. There is an option to restore factory settings. My firmware version today is 1.2.2. To exit the menu, press and hold button 4 again. In measurement mode, you can change the frequency 100 Hz, 120 Hz, 1 kHz, 10 kHz, and 100 kHz. You can also change the amplitude 100 mV, 300 mV, 600 mV. And you can select either automatic mode or specifically choose the parameters you plan to measure. To hold the data on the screen, press the power button. It's also the hold button. If you need to change the measurement speed, press and hold key 3. Medium speed, high speed, but I will perform all measurements at the low speed. And the first thing I'll do is calibrate with the closed channel. I close the channel, press calibration, and the calibration has started. Next is calibration using resistors, but I don't have a resistor set, so I'll skip that and look for open channel calibration. You also need to wait a little while. While the calibration is running, I'll show you this device. This is the LC1020E. It shows 5 digits. It has better resolution and measures some parameters more accurately. The ZOYI has 4 digits. The LC1020E uses a cable with Kelvin clips. The cable itself is shielded and quite long, about 40 centimeters. The shielding protects this cable from external electromagnetic interference because the measurement is performed at low voltage, 100, 300, and 600 millivolts. The tweezers don't have long wires, so the influence of external factors is minimal. In any case, I'll be monitoring the values today using this device. Now I'll show you how the scanning mode works. We select scanning mode and a value, for example, resistance. Here, series resistance, parallel resistance, and additionally the quality factor will be measured. Now I'll try to measure a 10 ohm resistor at 100 Hz, 120, 1 kHz, 10 kHz, and 100 kHz. In principle, there's no point in measuring resistance in scanning mode, but there is a point in measuring capacitance in this mode. We will measure a 100 picofarads capacitor. When scanning capacitance, the second parameter scanned will be the dissipation factor. Unfortunately, in this mode, the second parameter cannot be selected. When working with such devices, you must understand what you plan to measure and how it should be measured. For example, large electrolytic capacitors should preferably be measured at a low frequency, 100 to 120 Hz. The same applies to large inductors. Resistors are usually measured at a 1 kHz frequency. Small capacitors, for example, up to 1 microfarad, can also be measured at a 1 kHz frequency. The measurement amplitude can be selected as 300 or 600 millivolts. But if you are taking measurements on a circuit board, it's best to choose a 100 millivolts amplitude. I set it to 1 kHz, 600 millivolts, and now I'll remeasure the resistors, 10 ohms, 100.8 ohms, exactly 1 kilo ohm, 9.999 kilo ohms, and 99.91 kilo ohms. I switch to capacitance measurement and first will measure small capacitances. 100 picofarads, 1 nanofarad, 10 nanofarads, 99 nanofarads. And written next to this capacitor is 99 nanofarads, but the third device in a row shows that it's not 99 nanofarads, but 97.5 nanofarads. 946 nanofarads. And 10.2 microfarad. And this capacitor at 1 kHz frequency is measured by this device as 9.2 microfarad. It's necessary to reduce the frequency to 100 or 120 Hz. At 100 Hz, the result is 10.5 microfarad. 220 microfarads electrolytic capacitor. Don't forget to discharge capacitors before measuring. 217 microfarads. 470 microfarads electrolytic capacitor. And the FNRC LCR meter also showed 417 microfarads. Some multimeters can measure capacitance. For example, the Tooltop ET34S measures small capacitance as well. But it showed something around 500 microfarads for the 470 microfarads capacitor. So you definitely can't trust multimeters for this. Diode mode. I have a Schottky diode for the diode test. Voltage drop is 0.37 volts. There is a regular diode, and the drop on it is 0.7 volts. I remind you that the ZT-MD2 measures voltage drop up to 0.9 volts. If the drop is higher, it won't be able to measure anything. For example, the voltage drop of an LED is around 1.6 volts, and the LED doesn't light up, and nothing is measured. Inductors are ordinary, non-precision ones. I'll start measuring with 2.2 microhenries, then 10 microhenries, 100 microhenries, and finally 10 millihenries. Small inductance can also be measured at a 1 kHz frequency. 2 microhenries. Another component. 2.1 microhenries. 10 microhenries. (100 microhenries). And 10 millihenries. I switched to voltage measurement mode, and now I'll measure the voltage on the 8584 reference voltage source. I remind you that this board outputs 4 voltages: 10, 7.5, 5, and 2.5 volts. I've set it to 10 volts now. 7.5 volts. 5 volts. And 2.5 volts. The set includes a hard case and a cable for connecting to a computer or for charging, and also a manual which is not entirely up to date. When measuring the primary parameter, additional parameters will also be shown below. When measuring resistance, I see that inductance and quality factor are displayed below. A 10 millihenry inductor in resistance measurement mode. I'll increase the measurement frequency to 1 kHz. Resistance is 62 ohm, and inductance is 9.5 millihenry. Quality factor is 0.96. When measuring capacitance, you will see the dissipation factor, loss tangent, and equivalent series resistance ES below. At a 1 kHz frequency, the ESR is 250 milliohms, but it's better to measure this in scanning mode. Only in scanning mode, we select resistance as the primary parameter. And here will be RS series resistance, RP parallel resistance. And, as you can see, the ESR differs at different frequencies. In voltage measurement mode, the device also records the minimum and maximum values. In inductance measurement mode, it shows the quality factor and resistance. Connecting to a computer. To update it, press and hold the 4th key and connect to the computer. The message bootloader 0% appeared, and a drive appeared on the computer. You need to copy the .bin file with the new firmware to this drive. On the Chinese ZOYI website, I found the color program, version 1.0.4. It allows you to customize the device's interface. For example, I want the frequency to be green and the voltage to be red. I select green and red and press the middle button and look at my interface. Oh, there's green and red. I also found a new firmware on the Chinese website. From September 30th, 2025, version 1.2.4. So now I'll demonstrate how to reprogram it. I turn it off, press and hold key 4, and connect to the computer. The bootloader message. A new drive appeared. I go to this drive and need to copy the .bin file. The file in the archive will have brackets in the name. I recommend removing these brackets. Copy the file. The device turned off and turned on. And now the version here is 1.2.4, but I still haven't found the sorting mode. I turn on the device and connect to the computer again. This time the computer saw the drive, but it's inaccessible. A device with a USB serial interface appeared in the device manager. I downloaded the software from the Chinese website. I select port COM5. That's where our device is located on COM5. And now I'll try to connect. If you use Google Translate, it becomes clear that it is written in Chinese. And the program definitely has the ability to enable sorting mode. The device connected and I'll try to measure something. 218 microfarads, and on the screen you see 218 microfarads. I found this other interface. And I understand that these are the saved records. And there are quite a lot of records here. There is an option to export to an Excel file. We are waiting for the English version of the program, and I hope it will be clear which buttons to press. And the program has sorting mode settings. Now, using the Riggle DHO 804 oscilloscope, I will check the parameters of the measurement signal on the ZT-MD2. First, I check the amplitude and set the amplitude to 100 millivolts. The oscilloscope shows 97 millivolts, 300 millivolts, and 600 millivolts. Now let's look at the frequency 100 Hz, 120 Hz, 1 kHz, 10 kHz, and 100 kHz. I switched it to generator mode and now I'll see what signals it outputs. I immediately set the maximum frequency to 10 kHz, amplitude 3 volts. This is a PWM signal. I press the power key twice and can select another signal. Triangle. Steps. Half sine wave. But maybe I need to flip the oscilloscope probe. Oh, that looks like a half sine wave. PWM. Triangle. Steps. Half sine wave. Noise. Sine wave. I'll now try to raise the sine wave frequency to 100 kHz. The amplitude is set to 3 volts. The oscilloscope shows 1.8 volts peak to peak. I'll try to decrease the frequency. Frequency 50 kHz and peak to peak 2.5 volts. 10 kHz, peak to peak 2.9 volts. And at 1 kHz, peak to peak 2.9 volts. So at 100 kHz, you get a reduction in amplitude at the output. And this must also be taken into account. The device is very easy to disassemble, but you definitely shouldn't take it apart unnecessarily. To assemble it, you need to insert the board into the part where the buttons are installed. And be sure to make sure the buttons on the board don't bend. Inside, a 300 mAh lithium battery with protection was found. The case is aluminum and very well made. The microcontroller is from Artery. There are also contact pads for programming this microcontroller in case of an emergency. And there are a few more chips, analog to digital converters, operational amplifiers. The auto-off function does not work on this device currently, and this is a software issue. It's not fixed in firmware 1.2.4, but I hope they will fix it in future versions. I can draw conclusions. 10 years ago, one could only dream of such devices at this price. Now they are available and measure very well. The resolution is lower than that of larger devices. But for a home lab, this is an incredibly good tool. I recommend it. And on this, I will conclude the video. I will definitely leave the link to the Chinese website where I found the firmware and Chinese language software below, but I hope they will also release an English version of the program very soon. And that's all for now.